Memory metals. We've all heard of them, but do we actually know what they are? So what is a memory metal? A memory metal is an alloy that can remember its shape when heated above its transition temperature. They use the term remember because the metal is able to return to its original form. An alloy is a metal made by combining two or more metallic elements. This is generally done to alter a material's properties, like its strength, hardness, or melting temperature. Let's go through a brief history on memory metals. In 1932, Chang and Reed were the first to record their observations on the reversibility of the transformation of a gold-cadmium alloy. In 1938, the same observation was seen in brass. In 1951, the shape memory effect was observed in a bent bar of gold cadmium. In 1962, Buehler observed the shape memory effect in a nickel-titanium alloy. This nickel-titanium alloy is nitinol. Within 10 years after this, there were a number of commercial products using memory metals on the market. Now the question is, how does memory metal work? Shape memory metals change shape through solid-state transformations. This happens through rearrangement of the atoms in the crystal structure. This rearrangement of the atoms happens at the metal's transition temperature. A transition temperature is the temperature at which the crystal structure changes and can sometimes physically be seen. Nitinol, for example, has two solid-state phases. Its high-temperature phase is called austenite. Austenite has a cubic crystal structure and it's very rigid and hard. Nitinol's low-temperature phase is martensite, which has a monoclinic crystal structure. Martensite is less symmetric but more flexible than austenite. Because of this, with pressure, the atoms can rearrange. This phase is where the material can be deformed. Now, how do we make a memory metal? The manufacturing of a memory metal is the same as if you were to manufacture an alloy. The metal is heated and cast. In casting a metal, the metal is heated until it melts and then is poured in a mold or cavity until it has solidified. Two types of casting are die casting and sand casting. Die casting is a process in which the metal is melted and is poured or forced into a die. Sand casting uses sand molds to form complex metal parts. The sand mold has to be destroyed for the metal to be removed. Therefore, the mold cannot be used again. However, sand casting allows for intricate metal parts to be made. Now let's talk about some applications of memory metals. Memory metals can be used in broken bones. They heal a broken bone when the alloy plate with a transition temperature close to body temperature is attached to both ends of the broken bone. The alloy plate then wants to contract from the body heat, and it pulls the bone back together as it returns to its original shape. The blade then continues to exert a compressive force that aids in the strengthening of the bone during rehabilitation. Another application of memory metals is in clogged arteries and veins. An alloy tube with a transition temperature close to body temperature is crushed and inserted into a clogged vein or artery. The memory metal then expands. This opens the clogged artery or vein and allows for the blood to be moved and the clogged artery to open.